Welcome to Quick Engineering. The topic of today's video is non-deterministic finite automata. So in this video we will see what is non-deterministic finite automata, structure of non-deterministic finite automata, and difference between deterministic finite automata and non-deterministic finite automata. So let us start with non-deterministic finite automata. So non-deterministic finite automata is a type of finite automata. There are two types of finite automata: deterministic finite automata and non-deterministic finite automata. So why the name non-deterministic? Because in non-deterministic finite automata, for one input symbol there can be one or more than one transition for one input symbol. So that's why the name is non-deterministic. But in deterministic finite automata you will find one transition for one input symbol. So this is the difference, main difference between non-deterministic finite automata and deterministic finite automata. So let us see the structure of non-deterministic finite automata. So non-deterministic finite automata contains state, transition and input symbol. So here there are three states: Q0, Q1, Q2. Q0 is the initial state, Q2 is the final state. So that's why it is represented by double circle. So if you look here, Q00 is Q1, then Q10 is Q2 and Q10 is Q0. So for one input symbol 0 on Q1, you will find there are two transitions. Hence the name is non-deterministic finite automata. So non-deterministic finite automata is defined by 5 tuple Q sigma del Q0 F. So what is capital Q? Capital Q represent finite set of states. So here the states are Q0, Q1, Q2. So here Q is equal to Q0, Q1, Q2. What is sigma? Sigma is a set of input symbol. So here there are two input symbols 0 and 1, so sigma is equal to 0, 1. Then del is transition function. Transition function is defined by transition table. We will fill this transition table. Q0 is the initial state, so Q0 is equal to Q0, and F is equal to set of final state. So here there is only one final state, so F is equal to Q2. So this is the description of non-deterministic finite automata. Remaining part is transition table. So transition table is drawn from this diagram. So what is Q00? Q00 is Q1, Q01 is Q0, then Q10. So Q10 is Q0 and Q2. So Q0, Q2, Q11, Q11 is Q0, then Q20 is Q2, then Q21 is Q1. So this is how you have to draw the transition table. So this is the description of non-deterministic finite automata. Now let us see the difference between deterministic finite automata and non-deterministic finite automata. So in deterministic finite automata there is one transition for one input symbol, but in non-deterministic finite automata you will find one or more transition for one input symbol. So in deterministic finite automata there is no epsilon transition, but in non-deterministic finite automata there is epsilon transition. So there are two types of non-deterministic finite automata: non-deterministic finite automata with epsilon moves, non-deterministic finite automata without epsilon moves. So this is without epsilon moves. So all DFA are NFA, but all NFA are not DFA. So this is the difference between DFA and NFA. Both DFA and NFA contains some same tuple Q sigma del Q0F. So that's it for this video. If you like the video, please subscribe, like and share. Thank you.